we are given a piecewise defined function and we are asked to find the left-handed limit, the right-hand limit, and the limit in general. So let's take a look. If we are going to look at the limit as x approaches 1 from the left. So as we're coming up on our a value of 1, we're on the left-hand side, which means my x values have to be less than my a value. So I'm going to use my first function. So I will have the limit as x approaches 1 from the left of 4 minus x. All I will need to do is plug my a value in. The limit as x approaches 1 from the left of 4 minus 1 equals, oops, there goes my lead, 3. Let's look at b. Now we're going to take it from the right. So if I'm on the right-hand side of a, I'm coming in this way. That means my values for x have to be greater than 1. So I'm going to use the third function. Here we go. The limit as x approaches 1 from the right, my f of x is x squared plus 2. I'm going to go ahead and plug 1 in. The limit as x approaches 1 from the right of 1 squared plus 2. 1 squared is 1 plus 2 is 3. So now when I'm looking at the limit of f of x as x approaches 1, I'm coming at 1 from both sides. Since my my left-hand limit was equal to my right-hand limit, that means the limit as x approaches 1 is also 3. If these two were not the same, if the left-hand limit did not equal the right-hand limit, we would have limit does not exist. Let's look at number 3. We are going to factor. So here we go. If I plug in 3 here, I'll be undefined. So let's factor this. Limit as x approaches 3. I can factor out a GCF of 4, which is going to leave me 4 times the quantity x minus 3 all over x minus 3. These cancel out. And if you remember your properties, the limit of a constant is the constant.